Welcome to the Bentley Systems training course where you will learn how to model loads and generate load combinations in STAAD Pro Connect Edition. In this video, we're going to show you the complete workflow for modeling moving loads in STAAD Pro and reviewing their results. We will now turn our attention to a new sample model. Now on this model, what we're intending to do is to create a load that moves across a structure. In this exercise, we're going to demonstrate this workflow on a typical crane type structure, but you could also use this workflow to represent some type of truck or bridge loading. Now what we have so far is we just have a simple portal frame. Now our top beam along the top of this frame has been segmented for our exercise. It's not necessary for it to be segmented, but we did segment it because we wanted to have key areas of that we could review in the post processor once the analysis was complete. So let's go ahead and start our process. In the workflow page control area at the top of your screen, we're going to start by selecting the loading page, which is going to bring us back to our load and definition dialog. I'm going to expand my definitions area and also my load case details section. So what I'm going to do is I'm going to use a vehicle definition in order to define the load that I'm going to be moving across this structure. So I'm going to grab my vehicle definition in my load and definition dialog and click on the add button. You can also get to the same exact area by selecting the vehicle option within the loading tab in the ribbon toolbar. So what we're going to do is we're going to manually define our load. Again, the workflow we're looking at for today is to simulate some type of crane loading across the structure. In addition to being able to do that, you also do have the option to specify a standard HS20 truck or an H15 or an HS15 truck, if that works what you're trying to define. I'm going to go to the define load area, which is where you would define kind of a custom load with a custom spacing in between. And what we're going to do is we're going to start for the first load. Now this will be the front axle, the first load that hits your structure. So I'm going to enter 0.5 kips for my first load, and I'm going to do a series of closely spaced load. My second load is going to be 1 kip, and then the distance I'm going to define is basically the distance between load number 1 and load number 2. So for this exercise, I'll enter that at 1 foot. And I'm going to add another crane load. This will be 1 foot behind. Distance that I put in the 3 fields will be the distance between load number 2 and load number 3. Once we're satisfied with our vehicle load, we'll click the Add button, and then we'll go ahead and click Close. Now you could have additional vehicles if you needed to for this exercise. So I've gone ahead and defined my vehicle load. And now what I need to do is I need to tell the program I want to step it across my structure. So what I'm going to do is I'm going to use a load generator. It's a moving load command that's used to specify the direction and the path for a moving load that was defined from your vehicle load definition. So in the ribbon toolbar, I'm going to select my loading tab and then click on the load generator icon. Now, what I need to do is I need to decide how many loads I want to generate. My particular portal frame is 40 feet long. And what I'd like to do is I'd like to generate a load and investigate its effects on this portal frame, basically stepping it across every foot across the structure. I feel like that's a good representation of the effects of this load would be. So I'm going to tell the program I want to generate 40 steps. Once we're done, we'll go ahead and click the Add button, and then we'll click Close. Now the moving load will be derived into a number of positions of the vehicle along the direction of movement. Each position represents a distinct load case whose loads will be evaluated from the corresponding position of the vehicle in the structure. Now that we've basically created our generated or our moving load case, what we're going to do is we're going to add some more information to it. So I'm going to highlight this load case, come down in the load and definition dialog and click the add button. And basically what I need to do here is I need to tell the program where the initial position of my load will be. Now the initial position of the load will correspond to load number 3, or basically your final axle from your vehicle load definition. So I'm going to correspond that point with this exact point for this upper node from like that basically corresponds to the end of the beam member and the top of this column. So I'm going to enter the coordinates for that node, which happens to be at 0 feet in the global x direction, 10 feet in the global y direction, and the z coordinate is also at 0 feet. Then I'm going to tell the program how often do I want this stepped. I already told it I want it 40 steps, but it doesn't know the distance between the steps. So I'm going to say we're going to go in the global x direction every foot. So I'm going to put 1 here. Once we're done, we'll go ahead and click the add button, and then we'll click close. Now at this point, we are done specifying our generated load. And what we want to do is we want to use this command in order to investigate kind of a worst case scenario for where is the load going to be to give me my worst case shear or moment or deflection or whatever else you're looking for. So in order to get that information, we're going to have to run an analysis. So I'm going to save my model. Then I'm going to go to the Analysis and Design tab. Now this model already contains my analysis command, so all I have to do is click Run Analysis for this model. Okay, the analysis is done, and I'm going to go ahead and take a look at what we get when we have this type of load in the post-processor. So I'm going to tell the program I'm going to go to the post-processing mode, then I'm going to click on the Done button. Now over in this area, I'm going to choose to review just the effects of the moving load for now. So I'm going to actually move my standard dead load over. And you can see basically what the program did was it generated 40 load cases to represent each position of that load. That's basically how it evaluates it. So let me go ahead and set up the post processor the way I want it. And now we can go ahead and review those loads. Now, one of the things you might want to do is you want to turn on the loads on your model. So I'm going to come up here in the Results tab in my ribbon toolbar, and we're in the Post Processor now. I'm going to click on my View Loading Diagram. That's going to turn on my load arrows. If I want to investigate the position of the load for any of those 40 load cases it generated for me, I can come down here to my Loads pull-down menu, select the Generation option, and here are all of them. So here I can kind of push my load across the structure and see its effects. You're going to notice that your displacement diagram will be updated to kind of show you that information. So now at this point, we might want to review what our worst case scenarios are, where the worst case, the position of the load that would result in the worst case displacement or shear or moment. So let's go ahead and make sure we know how to obtain that information. So in my node displacements table over my data area, I'm now going to select my summary tab. And what I'm looking for is I'm looking for my maximum vertical displacement. So here I can see my maximum Y and my minimum Y. You can see here load case at node number 8 for load case number 21 is revealing basically my worst case displacement. If I wanted to see that kind of information for worst case shear or moment, what I'm going to do is I'm going to come over here and select my beam results, and I can view that information as well. So basically in the beam end forces table, again, I'm going to select my summary tab, and I can see my maximum shear, maximum Fy. Here I'm going to find that that's going to be a result of load case number 2. If I want to see my maximum moment, I'm looking for my max mx. And here I'm seeing that's for load case number 2 as well. So at this point, what do I want to do? If I want to, how do I take these results and make them, turn them into something real that I can use in my design? Well, what I may want to do is I may want to include these moving loads in kind of a load combination. So let's go ahead and take a look to see how we do that. So over in the workflow panel at the left-hand side, let's return to the analytical modeling mode. And I'm going to return to my loading area. Now, this is identified as a generated load, so I can't just automatically generate my load combinations the same way I would traditionally be able to do if I had a bunch of primary load cases defined. I can include these loads in a load combination though, but to do that, I'm going to have to manually create them in the stat editor or the input file. So let me go ahead and show you how to do that. Now I've identified load case number 2 and load case number 21 as kind of my worst case scenarios for things like moment shear and displacement. Load case number 21 is when basically the load is dead center, at midspan of my portal frame. Load number 2 is basically when it's, the starting point when it's at the end of the bridge structure. So let's go to the Utilities tab in the ribbon toolbar, and I'm going to click on my command file icon. And what I'd like to do is I'd like to include this in a load combination. So I'm going to go before my perform analysis command. And what I'm going to do is I'm going to have to manually enter in my load combination information. So I'm going to go ahead and save load combination number 42. And then I'm going to identify my load. So I'm going to say load case number 1, which is my dead load, 1.0 times that. Load case number 21, 1.0 times that. And then I'll repeat this for however many loads I want to kind of include in a design. So here I'll also add load case number 2. Okay. Now, as you've entered it, and of course you could include all of your generated load cases here, but once you're done, we'll go ahead and save this, and then we're going to go ahead and exit out of there. Okay. So once we're back in our analytical modeling mode, I'm going to expand this, and you can see I have my combination load cases, and it was able to include those loads from the generated case. Now at this point, if I went to run my analysis, I could see the combination of, I could see that load combination in my results if I wanted to. So here's combination case, the first one, and then also the second one. So I'd be able to review the results of one of those generated loads plus a dead load or any other primary load case that you might have.